Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Ein Sindane. Our lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our WhatsApp line has changed. Please take note. You are going to get hold of us on 079 578 2908. I will take it again, 079 578 2908. Our focus today is statistics, and we are going to focus on univariate data analysis, which means it's one variable statistic. And by the end of the lesson, we should be able to calculate the mean, the mode, and the standard deviation of univariate data, which is our one variable statistic. We should be able to determine the 5-number summary, and we use it to draw a box and whisker plot. We should be able to determine the range and the interquartile range of any given data set. We should be able to draw and interpret a box and whisker plot, and we should be able to identify outliers from a given data distribution. We should be able to draw and interpret a histogram for continuous data, and we will refer to our CAPS document on page 27 and 48, as well as our examination guidelines for grade 12, page 8. Please get your calculators and somewhere to write ready, because we are going to be doing some bit of work. It will be less talking, but more of us practicing what we have learned moving forward. Our pre-knowledge, we are able to determine the mean, the mode, and the median, standard deviation. We are able to draw and interpret bar graphs, histograms, pie charts, frequency polygons, frequency tables, stem and leaf diagrams. Please revise this. Remember, these are ways of representing our data in ascending order. So we should be able to interpret our stem and leaf diagrams, our ogives, which is our cumulative frequency graphs. Now, here is our baseline. I will give you 6 minutes to complete our baseline. Welcome back. I hope you were able to answer those 3 questions. Now, if you are having any questions, remember our WhatsApp line is 079-578-2908. Now, we are given the data. We are supposed to calculate the mean for the data set, and we are supposed to calculate the standard deviation for the data set. Remember our definition of the mean. It is the sum of all data items divided by the number of data items, and if I check, our data items are 9. So we sum up those data items and we will get a sum of 242. We divide it by the number of data items, which is 9, and we get 26.89 cans. Now we are supposed to calculate the standard deviation for the data. So to calculate the standard deviation, we are using a calculator, and we should get our standard deviation as 19.56. We'll get 2 marks for the answer there. 1.3 says determine the number of classes whose cans collected fall within 1 standard deviation. Now, falls within 1 standard deviation to the mean. Remember our formula, we know that it is x bar minus our standard deviation x bar plus our 1 standard deviation there. So our solution will be, we get the interval upper and the lower value, and then we are able to count. It's between 7.33 because our mean is 26.89. We subtract 19.56, we get 7.33. 26.89, which is our mean, plus 1 standard deviation, which is 19.56, we get 46.45. And then if you check, all this 8 falls within 15, it's within 25, 27, 31, 36. It's between 7.33 and 46.45. Therefore, we are able to count 1, 2, 3, 4, 5, 6, 7. So the number of cans collected by 7 classes fall within 1 standard deviation to the mean. Let's get on to our terminology. We'll define our data handling as the process in which data, and we must be specific, we are analyzing numerical data or numerical information, is collected, recorded, represented, and analyzed. Remember, this is to help us come up with a conclusion or to deduce something from the data that is analyzed. So with that being said, data, these are facts and numerical information that is being analyzed. It can be grouped or ungrouped. For ungrouped data, this is a set of random data elements gathered for analysis. These can be, for example, our shoe sizes, our heights in a class of 35, 40 learners. We are able to analyze that kind of information practically to find out what is the most common shoe size, or are we left-handed or right-handed, how many are left-handed, how many are right-handed, so that we are able to see the kind of data that we are working with. Our mathematics marks for the June exam, we are able to analyze those. How many got level 1, how many got level 2, what was our average, what was our median mark, and so on. For grouped data, these are elements that are aggregated into different groups or classes or intervals. So our mathematics marks for term 2 June exam, we can group according to the levels. We know that our level 1 is between 0 and 29.99%, our level 2 between 30 and 39.99%. Therefore, Whoever gets a mark there will be in level 2. We are able to count how many of us got that level, and we continue until we get to our level 7s. Now, for our analysis of our data, we have measures of central tendency. These are single numbers around which all data items seem to be spread around. So we have these items that fall under measures of central tendency. We have our mean, which is also known as the average. So mean and average mean the same thing. This is the sum of all data items divided by the number of data items in the set. Now, for grouped data, we calculate an estimated mean, and we use the symbol X bar for our mean, our summation sign, and for estimated mean, it is the frequency times the midpoint of each interval, and our N is the cumulative frequency or the total number of our items in the data set. And then our median, this is the middlemost data item in an ordered data set. In other words, we need to first of all arrange our data items either in ascending or descending order, and it will make more sense to arrange our data items in ascending order from smallest to biggest. Then we are able to determine the middlemost data item. And to get the position, it is half of n plus 1. That will give us the position. It won't give us the median, but it gives us the position for the median. The mode, this is the most frequent data item in the data set. And in most cases, the data item that has the highest frequency will give us the mode. And we should be careful here. We can have more than one mode if we are looking at ungrouped data. And for our grouped data, we can have also more than 2 class intervals that are our modes if they are having the same frequency. Now, we can have, I've already highlighted this, and then we have measures of dispersion. This gives us the spread of our data. We are looking at the spread. Central tendency, we are looking at around a certain data item. And measures of dispersion, we are looking at the spread. And we look at things like our range, which is the highest data item in the set minus the smallest data item in the data set. That gives us the range. We have our interquartile range, which is the difference between the upper quartile and the lower quartile. We also have standard deviation. This is a measure of how spread data is around the mean. And we know that the square of the standard deviation is variance. So if you are given variance, you are able to determine standard deviation by finding the square root. If you are given the standard deviation, you are able to deduce the variance by just squaring whatever the value is for standard deviation. Now, we move forward. We also look at quartiles. We can group our data items into quarters, in which case each of the quarter represents 25% of the data items in the set. Now, we have the lower quartile. To determine its position, we are saying it is 1/4 times n plus 1, where n is the number of items in the data set. Upper quartile, it is the 3/4 position, and we are saying to determine this position, it is 3/4 times n plus 1. That will give us the position of our upper quartile, which is represented by Q3, and our lower quartile is Q1, and our median is Q2, which means we are having a scenario like this where these are divided into quarters. We have our Q0, which is our minimum, our Q1, which represents our first quarter, and we have our Q2, which represent our second quarter, and we have our Q3, which represents our third quarter, 3/4, and we have our Q4, which will be our maximum. And remember, these form a box, and the tails will give us the whiskers give us from the distance from the minimum to the first quarter, and those are our whiskers. These form the box, and Q0 to Q1 gives us our whiskers, and then Q3 to Q4 gives us the other whisker. Now, we also have percentiles. Which data item will be the 70th percentile? So you want the position in terms of percentages. In other words, we are grouping our data items from 0 to 100 in order to position the data items in the groups of 0 to 100. We move on now. We look at representing our data. We know the methods of collections. We can use our surveys, our questionnaires, our observations to collect the data. We can represent the information that we collect using our tally tables. We can use our stem and leaf diagrams to represent our data. We can also use our box and whisker plots, bar graphs, histograms, and so on. So let's look at the 5-number summary. We have our minimum, we have our lower quartile, we have our median, we have our upper quartile, and we have our maximum value. These are the points that we plot on our box and whisker plot. And we use the 5-number summary to obtain this. And then we also have to comment on the skewness of our box and whisker plot. And we are saying if the mean is equal to the median, we say the data is symmetrical. And in most cases, if we are to draw our normal distribution curve, we'll have a normal distribution curve which is smooth, and it will look so symmetrical. Hence, we are saying the data will be symmetrical. So mean minus median, if it is equal to 0, the data is symmetrical. Our mean is equal to the median. And then we have our mean being less than the median, and we get, if we subtract, we get a negative answer. We say our data is negatively skewed, or it's skewed to the left. And you will find our normal distribution curve will tail more to the left. It will tail more to the left. And then we also have a scenario where our mean is greater than the median. When we subtract the median from the mean, we must get a positive answer, and we say our box and whisker plot, or our data that is being analyzed, is positively skewed. And this will give us, if you check, our normal distribution curve will tail to the right. Now, as we move forward, we should always know that in a symmetrical data set, approximately 68% of the data falls within 1 standard deviation to the mean, and approximately 95% of the data items will lie within 2 standard deviations to the mean. Now, That's when we have a symmetrical data set. Now, so 68% of the data items will fall within, and then 95% will fall within 2 standard deviations to the mean. Now, we also have outliers. These are data items that are a lot bigger or a lot smaller than the rest of the elements in the data set. To obtain our outliers, we use the following formula. Now we get our lower quartile, we subtract 3/2 times the interquartile range, and Q3, we add anything that falls outside that interval becomes an outlier. Now, let's look at the formula that we have on our formula page. These are the formula for statistics that we have. And we are saying when we are using our calculators, we must be in the statistics mode, and we choose the one variable statistic. We enter our data items and we are able to calculate whatever we're asked to calculate. Now, the first example, we are going to do it together. We are given a table and we are supposed to determine these are the number of plastic bottles that were collected on each school day of the 3-week by grade 8 recycling project. So the first question, we determine our mean, and remember what we said, it is the sum of all data items divided by the number of data items. So if I look at this, each week, school week has 5 days, so it is 5 days of each week we collected over 3 weeks. Hence, we are going to have 15 days of collection of our data items. So to calculate the mean, we will add, and this is how we get the mean. We got our mean as 101.47 bottles. Standard deviation, we are using our calculators. We can either use our Casio or our Sharp calculators depending on what we have, and we should be able to get our standard deviation as 19.07. 1.3 says, on how many days did the number of cans collected, of bottles, lie outside 1 standard deviation to the mean? Remember, the one we wrote was saying within, this one says outside. It's outside 1 standard deviation. So it means we must get our interval first, and then we identify those data items that are outside 1 standard deviation to the mean. So our mean is that one. Remember our formula. It is our x bar minus standard deviation, our x bar plus standard deviation, and this gave us our answer is 82.4, and our upper limit is 120.54. Now, if we check our data items, on how many days did the number of cans collected fall outside 1 standard deviation to the mean? So this will give us how many days? So we have 120.54, and we also have 82.4, and this means the only data items that are outside, it's this one and that one, which gives us only 2 days. Those are outside. And please, if we're answering questions here, we must be able to read the question correctly. The question can either be worded as within. We know we are counting those that are between the interval. Below, If it was below, it means it will only be 58 because that is the smallest, the one that is below the minimum. Above. So if it's above, you are only looking at the one that is above the upper limit. In most cases, this question will be 3 marks. You have your upper, you have your lower limit, and then you are able to calculate the number of days. And also, you should be able to look at the wording on the question. Sometimes instead of saying how many, they can ask us to calculate the percentage of days where the collection was within, below, above, or outside. So we answer the question accordingly. So in this case, if they said the percentage of days in which the number of bottles collected is outside, so it will be 2 over 15 times 100 to convert it to a percentage. So we should always read and answer the question according to how it is asked. Now, I will ask us to do the first activity and I will give you 7 minutes to answer these questions. Welcome back. I hope you were able to answer those 4 questions. Remember, you enter your data items once and you are able to answer all those questions. Remember, our WhatsApp line is 079-578-2908. Please, if you are having any questions relating to the lesson that you are doing, please send them through. Now we are given a group of 30 learners, each randomly rolled 2 dice once, and the sum of the values on the uppermost faces of the dice was recorded. The data is shown in the frequency table on the side. Now, it means the sum of the 2 dice was 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the sum of the 2 dice. Now, calculate the mean for the data. How do we calculate the mean? So remember, for us to get the mean, we multiply our data item by the frequency. So this will give us 2 times 0, 3 times 3, 4 times 2, because it means we have 4 data items. We have 2 data items with a value of 4. We have 4 data items with a value of 5. So this becomes 5 times 4. This is 6 times 4. This is 7 times 8. And this is 8 times 3. And this is 9 times 2. And this is 10 times 2. And this is 11 times 1. This is 12 times 1. We add this sum. It will give us our sum of all data items, and then we'll divide them by the total frequency. I made it easy there. It's 0, which we write first, plus 3, plus 2, plus 4, plus 4, plus 8, plus 3. You get 24, plus 2, you get 26, plus 2, you get 28, plus 1, you get 29, plus 1, you get 30. So that is the total sum of our frequencies. Now, so to calculate the mean, this is what we did, and we got our answer as 6,73. The median for the data, remember we are arranging our data items in ascending order, which means if I am to represent this, I will have no 2, and then I will have 3, 3, because here in my first position there is nothing. So 3, 3, I must have 3 3s. I must also have 2 4s. I must also have 4 5s. I must have 4 6s. I'm arranging it in ascending order, but this becomes so time consuming because if you jump 1 6, it means you have to start afresh. So we position our data items from position 1, 2, 3, 4, 5, 6, 7 until position number 30. So we are saying to determine the median, so we are having 30 data items. Remember we said the median position, it's 1 over 2 n plus 1, and our position will be 15,5, which means our median should be between position 15 and position 16. And this is going to help you. 6 is in position 13, which means from position 13 until position 21, we are having 7 as the data item in those positions. So we are repeating 7 8 times. So that will give us our position 15. In position 15 and position 16, we'll have a data item with a value 7. So we add the data item in those positions and we divide it by 2 to give us a median of 7. So that's how we get our median. We have to determine the standard deviation. We are using our calculator and we got our standard deviation as 2,26. We have our 2 marks there. So here, if you are using a calculator, answer only, you get a mark. If you show the step of the sum, you get that mark and the mark for the answer. So it depends on how you are doing it. If you show the sum, divided by 30, you get 1 mark, and for the answer. If you don't show this, you only show 6,73, you'll get your 2 marks there. We move forward. The number of times that the sum of the 2 recorded values of the dice is within 1 standard deviation to the mean. So we will have our x bar minus standard deviation, x bar plus standard deviation. And this will give us an answer of 4,47 as our lower limit and 8,99 as our upper limit. Remember, we come here, it has to be, so we are counting from 5 up to 9. So 8,99, it means we can't include the data items that are more than 9, so we stop at 8,99. So if you check this, this is how we get the number. It is going to be 4 plus 4 plus 8 plus 3. And this will give us 19 times. That is what we will get. The number of times where the sum in our 2 dice will be between 4,47 and 8,99. It is going to be 19 times. In other words, 19 of the 30 learners obtained a sum within 1 standard deviation to the mean. So if they said percentage, you would now say 19 over the total number, of which is our frequency 30, you convert it to a percentage. And we should be able to get the answer as a percentage. We move on. Now, this is supposed to be an example, but I want us to do it. It's our work. We have done this, and I will give you 6 minutes to answer 1.1 up to 1.6. Welcome back, our grade 12s. Now, we are given the table that shows the number of cans of food collected by 9 classes during a charity drive. Now, how many data items are we having? We are able to see that. This is our data item number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9. I'm circling the positions so that we don't take those as our data values. So we are supposed to calculate the range. We said our range, it's maximum minus minimum. Our maximum is 75. We subtract our minimum, which is 5, and we get our range as 70. The median for the data, we have 9 data items, so it is half of 9 plus 1, which gives us position number 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our position 5, we take the data item in position number 5, and that will give us our 5th position, and the median will be 25 cans. The interquartile range, it will require us to calculate Q1, and if you check, that will give us 1 over 4 times n plus 1, which is 9 plus 1. 1 over 4 of 10, that will give us position 2,5. So we will take the data item in position 2 and position 3. We add them together, divide by 2. Our Q1 will be 11,5. The upper quartile, it will be 3/4 times 10. That gives us our position 7,5, which means we take the data item in position 7 and 8, we add them together and we divide by 2. That will give us 33,5. From there on, interquartile range is given by Q3 minus Q1, and that will give us 22 cans. Sometimes we ask about the mode. This data set will not have a mode, so if they say determine the mode, you just say there is no mode or none, because all the data items appear once. So there is no data item that has the highest frequency. All of them have a frequency of 1. So here we do not have the mode. 1.4, we have to draw a box and whisker plot. Remember, our minimum is 5. We have determined our Q1, and so that's our minimum. Our Q1, it helps. And please, I'll encourage you, just write the values here. Our Q1 is 11,5. Our Q2 is 25, so that we are able to easily see when we are being marked. That's our Q2. Our Q3, we said this is 33,5. And our maximum, we said it's 75 for ease of identification. Now you get your 2 marks for the box. So for the correct box and for the correct whiskers, minimum and maximum, you get 1 mark, and for the box 1 mark, because you have already been awarded marks for them in the previous questions. That's why it's only 2 marks here. We have to describe the skewness. So we can say it is skewed to the right or positively skewed. Remember, for us to determine the skewness, we are not looking at the length of our boxes. Remember, each of these represents 25%, 25%, 25%, 25%. So the length of this just gives us the spread. If the length of the box is small, it means our data items are all clustered around certain values. They are not spreading too much. Now, and remember now, how do we determine skewness? We can use the mean and the median. This is the same question. We got our mean as 26,89 and our median is 25. So the mean is more than the median. That's why we are saying it's skewed to the right. Or if you look at our whiskers, our right whisker is longer than our left whisker. So it means that's why we are saying it's skewed to the right as well. We look at the length of the whiskers, not the boxes. So this one is small, so our data is skewed to the right or positively skewed. We have to identify outliers. Remember, we calculated our Q1. We got it as 11,5. And our Q3, we got it as 33,5. We add and subtract our interquartile range and we'll get our smallest value will be negative, which falls within 1 standard deviation within our outlier range. It's negative 21,5. That's our lower limit. Our upper limit is 66,5. And it means only 75 is our outlier. 75 is our outlier because it is above the upper limit. So we get our 1 mark there. Moving forward, that's the second activity, but I'll quickly go through it. The range, we check our data items are already sorted in ascending order. So our range will be 145 minus 58, and that will give us a range of 87. The median, this is our position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So to determine the median position, we are going to say half of 15 plus 1, half of 16. We take position 8, and in position 8, our data item is 100. So we get that as 100 bottles. We get our 2 marks. Oh, this was 1 mark, so we just get our 1 mark as 87. The interquartile range, we get our Q1, which should be position number 4, and in the 4th position we have 89, and in our 12th position we have 113. So our interquartile range becomes 113 minus 89, and it gives us 24 bottles. That's our, so we get that, and for the answer of 24 bottles, we get our 3rd mark. Moving forward, we have to draw a box and whisker plot for the above data. Our minimum is 58, our maximum is 145, and we get our box and whisker as that. We have to describe the skewness. Remember, we did this. We got our mean as 101,47, and our median, which is our Q2, is 100. And if we look at that difference, it's so small. So we can just say it's marginally skewed to the right, or we can say it's positively skewed marginally, or we can even say it's almost symmetrical. Now, if you check the mean and the mode, the median, the difference is small. Also, if you look at our whiskers, this one, I think it's 31, this one is 32. We are saying 145 minus 113, you get 32. 89 minus 58 is 31. So the length of our whiskers is also almost the same, hence we say it's almost symmetrical, or we can just say it's marginally skewed to the right. We have to identify outliers. Remember, we got our Q1, we got our Q3, we add and subtract 1,5 times the interquartile range. Please note that 1,5 is the same as 3/2. So some literature uses Q1 minus 3/2 times IQR. It is the same thing. And this will give us our answer as our data item. Our interval will be 53 until 149. In this case, there are no outliers because all our data items are within the given interval. 58 is more than 53. 145 is less than 149. Hence, all the data items will be within, hence there is no outlier. Moving forward, we want to look at our grouped data. This is the classification of putting individual observations into classes. As I indicated, if we look at our levels of achievement that we use to allocate our grades for marks, we know that 0 to 29,99 it's our level 1, 30 to 39,99 it's our level 2, and so on and so on. So that's our class intervals. So we are grouping according to the interval that one falls into, and we are saying between 10 and 20 we have that interval. We also have our lower limit as 10 and our upper limit as 20, and we also say the class interval becomes 20 minus 10, it will give us 10. And for our grouped data, we use it to represent continuous data. This is data that can take any number form. As I indicated, our heights, it's one example that we can use for continuous data. And then we also have, I've talked about our marks. We can use them to represent grouped or continuous data. A histogram is used, and remember, a bar graph is used to represent discontinuous data. For example, if I were to say in your class, take those that are left-handed and count those that are right-handed, and you'll be able, because those are distinct characteristics that human beings show. It's either you are left-handed or you are right-handed. There can be yes, they are there that are in between, but you'll find there is always one hand that stands out, which means you are able to say is left-handed or right-handed. Now, and we are saying histogram, there are no gaps in our bars, but in a bar graph there are gaps in between the data items that we are analyzing. So we are saying using for our continuous data to come up with a histogram, the bars have to be in contact. There shouldn't be any gaps between the bars. And we are saying these represent our rectangles with our frequency on our dependent variable side or on our y-axis, and the characteristic that we are our class interval on the x-axis. The midpoint of the interval, you add the lower value of the interval and the upper one, you divide them by 2, you get the midpoint. That's what you use to plot what we call a frequency polygon. And the frequency polygon will give us the shape of our represented data. We don't leave gaps, I've indicated that. And the model class is the class interval with the highest frequency. And The frequency polygon indicates the number of occurrences of each distinct class of the data set. And we know that a frequency polygon is drawn by first plotting the midpoints of each class against their corresponding frequencies, then joining the points using straight lines. Now, we also have an Ogive, others call it an Ogive, which is our cumulative frequency graph. We use it to represent continuous data, and that will be our activity for now. We have a company that recorded the number of messages sent by email over a period of 60 working days. The data is shown in the table below. We have to calculate the estimated mean. We have to draw a cumulative frequency graph, which is our Ogive, but because we do not have a graph, it will be just an estimate. Hence, estimate the number of days on which 65 or more messages were sent. I will give us 6 minutes to answer those 3 questions. Welcome back. Remember our WhatsApp line 079-578-2908. It's at the bottom of your screens there. Now, for us to calculate estimated mean, remember we said we must get our midpoints. So to get our midpoint, we add the data items in our interval, and this should give us our 10 plus 20 is 30 divided by 2, so we get 15, 25, 35, 45, 55, 65, 75, and 85. Now, to get the sum, you multiply the midpoint by the frequency, 15 times 2, 25 times 8, we have 35 times 5, we have 45 times 10, we have 55 times 12, and we also have 65 times 18. We also have 75 times 3, and we have 85 times 2. We add this, it should give us a sum of 3080, and we are dividing this by 60, we get 51.33 messages. So it's a method, division by 60, and answer, we get our 51.33 messages. 1.2, we are supposed to come up with an Ogive, and for us to draw an Ogive, we know very well that we need to plot all the points. So to plot our points, we will first of all do our cumulative frequency. We are having a 2 there where we start. 2 plus 8 will give us a 10, plus 5, we get that 15, plus 10, 25, plus 12, 37, plus 18, 55, plus 3, 58, plus 2, 60. So we plot our upper values. So 20 goes with the cumulative frequency 2, 30 goes with the cumulative frequency 10. So these are the points that I'm going to plot. So it will be 20 and 2, it's somewhere there. I will also have 30 and 10, it should be somewhere there. I should also have 40 and 15. 15 is there. I should also have 50 and 25, somewhere there. I should also have 60 and 37. 35, 36, 37 is there. And then I will also have 70 and 55. 70 and 55, it goes up there. And then I will have 80 and 58, 58, 55, 56, 57, 58, and then I will have 90 and 60. Now remember, there's another point, we always have to ground our Ogive, so our grounding, it will go there to our lower limit, it's 10 there, so our low, it goes to 10 and 0. We must plot that point from there. We join those points using freehand, and we terminate our graph there. It shouldn't go beyond. We use freehand, good people, we don't use a ruler, and that should give us our Ogive as that. There is a question which asks us to find those where we had more than 65 messages. So we will go on our x-axis, we look for 65, and then we take a reading on our graph, and that gave us 46, and to get the answer it becomes 60 minus 46, and we get our solution as 14 days. But we'll accept, because as you can see, you are using freehand. Some of us, our curve never goes straight, but it has to be within the acceptable region. So it has to be between 45, what you read is should be between 45 and 49, so that we get our answer between 11 and 15 days. Any answer there, you will get it correct. Moving forward, sometimes we are expected to interpret our Ogive as it is given here. A company conducted a research among all employees on what percentage of their monthly salary was spent on fuel in a particular month. The data is represented in the Ogive, which is our cumulative frequency graph on the right. Now, this one we are doing it together. How many people are employed at this company? Now, from this, you are able to read, because here we have our percentages, here we have our cumulative frequency. The last point there will have coordinates 35 and 60. So our answer there, how many people are employed? We read it from the graph. It will be 60 people. The next one says, write down the modal class interval for the data. Looking at our data set, where do you seem to have a big jump? In our data set, we are able to see that it's between 20 and 25. Check, we are having 25 and 45. You are having 20 and 20 something. So that's where you have the biggest jump in terms of our frequency. Hence, we will take that as our model class. It will have the highest frequency if you look at it there. How many employees spent more than 22.5% of their salaries on fuel? Again, it's already drawn for you. So this one, you look at the scale. 15, 20, so it means this one is a 2.5 gap, 2.5 gap, 2.5 gap. 5, 7.5, and so on and so on. So 22.5 is this one. You take your ruler, go up, then you take a reading that side. And this will give us on how many employees spent more than. So more than, it means it's from here going that way. So we are going to work it similarly. This will be 60 minus. And if I read well, this gives me about, so that's my 30, 32, 34, yes. So that means it's 40 minus 34, and this will give me 16 employees, or it gives us 16 employees in this case. We are done here. We move on to the next one. We are asked 1.3. An employee spent 2,400 of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel. These are our ratios, rates, and proportions. So we are saying 7% is equivalent to 2,400. How do we get the original salary? So the salary becomes 2,400 rands divided by 7%. And we know that 7% is 0.07. So this is 2,400 divided by 0.07, and we'll get our answer as 30. 4,285.71. Now, or you just say 2,400 times 100/7. It will give us, because we are dividing by 7%, it will give us the answer there. The last question is asking us, the monthly salaries of these employees remain constant and the number of liters of fuel used in each month also remains constant. If the fuel price increases from 21 Rand 43 to 22 Rand 79 per liter at the beginning of next month, how will the above Ogive change? So our Ogive will become steeper, or it will move to the right. So these are interpretation questions that require us to have a deep knowledge and understanding on the effects of changing something on our information, and we must answer more of those questions. We don't just say it will change. You must give specific changes that are observable. With that being said, I thank you all for watching, and in summary, we are saying we have to perform calculations on measures of central tendency, measures of dispersion, and solve statistical problems. We should be able to determine the 5-number summary and be able to draw a box and whisker plot. And we should be able to plot and interpret Ogives. And we should be able to use statistical summaries, which is our measures of dispersion and central tendency, the graphs, to analyze and make meaningful comments on the context associated with the given data. Next week, we are going to continue with statistics, but we are going to be dealing with our scatter plots and regression analysis. Thank you so much for watching. Have a good afternoon.